Hello there guys, in today's video we are going to be learning about bonding. Now let's ask ourselves, what is bonding? So in the sense of chemistry, bonding is basically the joining or the connection of two atoms in a stable arrangement. So as an example, let's say we have H2. Now how would you denote this in a structure where it's shown that it's bonding, or the Lewis dot structure rather? We would write it like this. Before we connect them, let's denote the electrons that they have. So for hydrogen, we know there's one valence electron for all of them. So it should look like this or something like this. And if they were to be bonded together, it should look like this. So these two are basically the same thing. So why do we perform bonding? Or why is it a need? Why is it something we have to learn about in basic chemistry? This is because bonding is what atoms need to attain a complete outer shell of valence electrons. Let me introduce you to the octet rule. The octet rule basically means that an atom's valence shell is completely filled with the electrons it needs to have a stable arrangement. And a stable arrangement would be an arrangement that makes them isoelectronic with noble gases, because noble gases are stable enough to not have the requirement of bonding with other atoms to complete their valence shell. It means it has the same number of valence electrons as, let's say, the nearest noble gas in the same period. So if we have carbon being isoelectronic with a noble gas or being stable means that it's isoelectronic with the nearest noble gas, which would be neon. And neon has 8 valence electrons, while carbon has 4. Meaning to attain that isoelectronicity, we would need 4 bonds around carbon. And those 4 bonds contain the electrons that carbon needs to acquire a full valence shell to satisfy the octet rule. So basically, the octet rule means adding enough electrons for an atom to have 8 electrons around it. Now let's go back to the concept of bonding. In bonding, atoms can gain, lose, or share electrons depending on the situation to, like I said earlier, have the same number of electrons as the nearest noble gas in the same period. So what types of bonding are there? So for our first type of bonding, we have ionic bonding. Now what is ionic bonding? Ionic bonding is most commonly known as the bonding between a metal and a nonmetal. So let's say we have sodium and an OH. So what this would look like in a Lewis dot structure should be something like this. This basically denotes the electrostatic force around the system that allows it to bond with the OH. But the main thing here is we have to know that ionic bonding is not the sharing of electrons, it's the transfer of electrons. So this bond right here, it's not a shared bond, rather it's the transfer of an extra electron to the more positive side or the more electrophilic side to allow those two to bond. And that's basically ionic bonding. Now let's move on to the next type of bonding, which is covalent bonding. Normally, covalent bonding is known as a nonmetal plus another nonmetal. But how else can we describe covalent bonding? Covalent bonding is the sharing of electrons, which makes it slightly easier to understand. Let's say we have CH4. So this is methane. This is one of the basic compounds that you'll encounter in organic chemistry. Let's draw it in Lewis dot structure. So, as you can see, unlike the ionic bonding, there's no bracket or a charge symbol. So for this, all of these bonds are sharing of electrons, as carbon has 4 valence electrons willing to share some room with the singular valence electron that each hydrogen atom has. So let's carefully try to understand what that means. So let's redraw the dot structures. So hydrogen has 1 each, or rather 1 valence electron each. Then carbon has 4 to give away. So these valence electrons will bond with each other. 1, 2, 3, 4. And these are all sharing the same space. They're sharing the electrons with each other. So there should be a force pulling them towards each other. You'll learn more about this with the concept of electronegativity, which I can discuss in a different video. So let's summarize this. Covalent bonding is a 2-electron bond. As if we have H2 again, there's 2 electrons that will bond with each other, sharing that space. That's it. Remember, covalent bonding is the sharing of electrons, and ionic bonding is the transferring of electrons. And that's it. So, with that out of the way, let's move on to a sample problem. Label each bond in the following compounds as ionic or covalent. So for the first one, F2, what would this be? This would be covalent. Why? From the surface, we already know that this is a nonmetal, fluorine, plus another nonmetal, still fluorine. So, we have F with 7 valence electrons around it, and another F with 7 valence electrons around it. Bond that together, they're sharing that space, so F2 is covalent bonding. But the question is if it's a covalent or ionic compound, meaning this is a covalent compound. And moving on to the next question, we have lithium and bromine bonded with each other. So this, off of the surface, is a metal plus a nonmetal. Lithium is found in group 1A, and bromine is a halogen. So lithium plus bromine, that would be a transferring of electrons, meaning that this is an ionic compound. Moving on, CH3, CH3. How would you draw this in its Lewis dot structure? Rather, its Lewis structure would look something like this. So that's an ethane. Now, what does this tell us? This is a covalent compound, as we see no metals anywhere. And that's it. Next up, we have Na, NH2. That would look something like this. So that's sodium plus NH2. Let's just draw it like that. But you can also draw it like this. One, two, three, four, five. There's a free electron here. So that means you can draw it like that. And then that electron would be transferred to the sodium, making this an ionic compound. Next we have NaOCH3. Now let's redraw that. Na plus, and we have an O bonded to a CH3. That's 1, 2, 3, 4, 5, 6. And whatever extra it has just gets transferred to sodium. So again, this is an ionic compound. Ignore this right now. Just know that off of the surface, there's a metal and there's a non-metal group here. So the free atom would transfer its extra valence electron to the sodium, meaning that this is an ionic compound. In organic chemistry, we can predict how many bonds an atom would form in an organic compound. But how can we determine that? So it's actually simple. For atoms with 1, 2, 3, or 4 valence electrons, let's rewrite that. 1, 2, 3, or 4 valence electrons, they can form 1 bond, 2 bonds, 3 bonds, and 4 bonds, respectively. So for 1, you can form 1 bond. For 2 valence electrons, you can form 2 bonds. For 3, it can form 3. And for 4, it can form 4. Now how about the atoms with 5 or more valence electrons? We just have to use this equation. So the number of bonds be equal to 8 minus the number of valence electrons. So let's say you have an oxygen atom. The valence electrons of oxygen is 6. So how many bonds would that form? That would be 8 minus 6, which is 2 bonds. So normally in organic compounds, you would see oxygen with 2 lone pairs and 2 bonds next to it. And that's it. So let's go ahead and answer a sample problem. Now, how many covalent bonds are predicted for each atom? We already know that for oxygen, it's 2 bonds. How about aluminum? Where is aluminum? Aluminum can be found in group 3A. Now, how many valence electrons do we have in group 3A? 3. meaning that aluminum can form 3 bonds. Should be able to form 3 bonds. How about bromine? We learned earlier that bromine is a halogen, which is in group 7A, which means that it has 7 valence electrons. So we would use the equation. 8 minus 7, it's 1 bond. So normally you would see bromine or any other halogen like this. And that's usually what it looks like in an organic compound. How about silicon? Where is silicon? Silicon should be in group 4A, meaning it has 4 valence electrons. Now, what does that tell us? Respectively, from 1 to 4, it should have the respective amount of bonds. So if this is in group 4A, it has 4 valence electrons, meaning it has 4 bonds. And that's basically it. That's all for our lesson today. Thank you guys for watching, and leave a like, share, and subscribe. Thank you for watching, and I hope you learned something.